All right, today we are talking about inscribed angles. And your essential question is, what is the relationship between an inscribed angle and its intercepted arc? So be on the lookout for the answer to that question during the lecture. Okay, so what is an inscribed angle? An inscribed angle is an angle that's drawn inside of the circle. It's inscribed, but it also has to touch the outside of the circle. So this is not to be confused with central angles. A lot of people get those two confused. So this one is an inscribed angle. Okay, it touches the outside of the circle. Okay, a central angle is when it comes through the center, like that. See the difference between the two? So this one is a central angle, and this one is the inscribed angle. That's what you want. Okay, now the intercepted arc is the arc that is within the inscribed angle. So for example, if I have angle ACB, that is my inscribed angle. The arc that is within that angle is the arc between, which is AB. You can kind of think of it as like the slice of pizza, okay? If I want to finish this slice of pizza, I have to have this rounded edge, which is my intercepted arc. So angle C, or angle ACB, same thing, is the inscribed angle, and arc AB is the intercepted arc. Notice the notation on these. For angles, we use the angle symbol in front, and for arcs, we have to have this curve over the letters to show that it is an arc. Okay, now, the inscribed angle theorem says that the measure of an inscribed angle is half the measure of the intercepted arc. So there's the answer to our essential question right there. The inscribed angle is half the measure of the arc. Remember, arcs are measured in degrees, and so are angles. So whatever the measure of the arc is, the angle is half of that. Okay, so for example, angle C on our previous page, from the previous page, was 1/2 of the measure of arc AB. So that was from the previous slide. Okay, in your notes you can make a note of that. Okay, now we're going to do an example. See if you guys understand. So we're going to find the values of A and B. So if we look at this picture here, we have this nice circle. We have A, that is this arc up here. This represents the arc for A. And this angle is the angle for B. Let me switch colors so I can show you that. So this is angle B right here. Okay, so remember, the inscribed angle is half of the measure of its intercepted arc. So if we look at this arc right here, this blue arc, which angle does that go with? Let's finish our drawing. So here's it starts right here and it ends right here. And this angle right here also starts and ends at those points. So this piece goes together. This 60-degree angle goes with arc A. Okay, so if I know that the angle is 1/2 of the arc, 60 would be half of what number? Okay, well, to get A, 60 times 2 gives us 120 degrees, which is A. All right, so when you're looking for inscribed angles and intercepted arcs, find the points where they start and end and finish the angle and the arc picture together. That will help you out. So let's switch to our red pen. And right here, this was our inscribed angle, and the arc that goes with that, it starts here and ends here. The arc that goes with that is this whole thing. Okay, so it's like all of arc A plus this little 30-degree arc right here. So if I take A, which was 120, plus the 30 degrees that was there, I get 150 degrees. Now, is that what B is equal to? Is it equal to the arc? No, it's not equal to the arc. Silly, it's half of it. So we have to divide it by 2, and so 75 degrees would be B. Alrighty? I don't really quite know why I ended up changing the color on that. Sorry, it's bothering me. Okay, so let's go back. Next part, moving along. Corollaries to the inscribed angle theorem. Okay, a corollary is like an extra little bit added on to that theorem. Okay, these are things that go with that theorem. Okay, if I have two inscribed angles that intercept the same arc, they are going to be congruent. And that just totally makes sense. Okay, two inscribed angles that intercept the same arc are going to be congruent. Because if they start and end at the same point, then they're going to be attached to the same arc. And so since they're both half of that arc, they're going to have the same measure. Weird how that works out. Okay, and number 2, an inscribed angle in a semicircle is a right angle. Well, let's break this down. Okay, so a semicircle. How much is a semicircle? It is 180 degrees because it is half the circle. And so half of 180 degrees is 90 degrees. Da, 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 a right angle. So that totally makes sense. And this one's kind of cool. The opposite angles of a quadrilateral inscribed in a circle are supplementary. Ooh, that's a cool word. So supplementary, what does that mean? It means they add up to what? 180 degrees. Yeah. Okay. So let's do an example. All right, let's look at these two. It says find the measure of the numbered angle. So take a minute to go ahead and copy these two pictures. And if you want to go ahead and pause the video and try it on your own, that's cool. And then you can check and see if you got it right. So find the measure of the numbered angle. Okay, so in this first picture, we have number 1 right here. That's angle number 1. Let's go ahead and highlight that angle. So this angle goes like this. Okay. So remember, it starts here and it ends here. And so if I look at the arc that goes with that angle, what do I notice? The arc that goes with that angle is half of the circle, which is 180 degrees. So these other numbers I didn't even need them. So half of 180 degrees is 90 degrees. And you can kind of tell by the picture that this looks like a right angle. Okay? All right, moving along. Angle number 2. Okay, angle number 2 is this angle right here. If you trace over it with your pencil or like highlight it with a different colored pen or something, that would probably really help you see this a lot better. So angle number 2 starts here and ends here. And so the arc in between is this arc right here. Now, I don't know the measure of that arc, but let's see if I could use something else in the picture to help me find it. I notice that there is another angle that starts at this point and ends at this point. It is this 38-degree angle right here. So this 38-degree angle right here also intercepts this same arc. And so these two are going to be congruent. And if you haven't figured that out yet, angle 2 should be 38. But if you're not quite sure that that's true, you could check, because if we take 38 times 2 to get the arc, okay, so you can also do it that way. If you take 38 times 2, you get 76. So this is 76 degrees. And then remember, this is going to be half of 76 degrees, so we're just dividing by 2 again, which still gives us an answer of angle 2 equals 38 degrees. Pretty easy. All right. Now, that is the end of the notes. So make sure you go ahead and write a summary and answer the essential question. It's pretty straightforward this time. You guys have a book assignment. I'm going to go ahead and do some examples from that book assignment. If you want to go ahead and grab a piece of paper and write these down. So number 9 from your book assignment. It says find the value of each variable. Okay, so I've got angle A here, and I've got arc B up here, and I've got arc C over here. Now this one's kind of confusing because there's not really any intercepted arcs and angles that I can see that kind of go together. It's kind of different. So, because if I look at angle A, if I start with that, here's my inscribed angle, and my arc that goes with that, if it starts here and ends here, is this whole thing all the way around the circle. But I don't know what part B equals, so I can't really figure that out yet. And there's not really an inscribed angle that goes with B because there's kind of two angles that go there, and there's not really an inscribed angle that goes with C. So how am I supposed to figure this out? Well, if you go back to your corollaries of the inscribed angle theorem, number 3 said that inscribed angles in a circle that form a quadrilateral are supplementary. So if I go back and read that again, opposite angles in a quadrilateral are supplementary when they're inscribed in a circle. So I can figure out what A is because I can look at the angle across from that. So if the angle across from angle A is 68, and I know that those angles are supplementary, then how do I figure out what angle A is? Well, I can take 180, because supplementary means that they add up to 180 degrees, and I can subtract 68, and so then I get 112 degrees is angle A. Ta-da! So we'll fill that in. This is 112 degrees. Okay, and so then, because I know that this is 112 degrees, and this arc goes with that angle, okay, I know that this intercepted angle is half of this big arc right here. So if I take 112 times 2, I get 224 degrees, and that is the measure of the entire arc right here, the whole thing. So if I just want this part, if I just want part B right here, then I can take 224 and I can subtract the 104 right here. And so I get 120 degrees is what B is. So B is now 120 degrees. All right, so that leaves us with part C. Okay, now there's probably a few ways you could do this, but the easiest way that I see to do this is that 68 degrees is this inscribed angle right here, and that goes, it starts here and ends here, and so that goes with this intercepted arc right here, which C is a part of. And so I know that this is half of the arc outside, and so if I take 68 times 2, that will give me the measure of my intercepted arc. And so 68 times 2 is 136 degrees. So this whole thing on the outside is 136. And so let's see. Okay, so we can't do that because that doesn't really help us. But sometimes you just have to keep trying different ways to solve these. So if I do that, that gives me this whole thing, but there's no way that I can find C from that. So let's try another way. So let's try to do something using the quadrilateral. What do we know about quadrilaterals? Let's back up here. Quadrilaterals. We know that the angles of a quadrilateral add up to be how much? Okay. All right, just kidding. Just making sure you're paying attention again. That won't work either, because if we find this angle, that is not going to help us find angle C. I don't know what I'm doing today. So let's try another way. Okay, well, I think I found it, finally. So right here, this angle right here, angle 71, goes with this entire arc right here. There we go. So 71 times 2 gives us 142 degrees. So this whole thing is 142, and I can subtract off 104 to find out what is left over. So 142 minus 104 gives us 38 degrees, which is part C. Da, 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 da. So that one took us a while, but we got it. All right. Next. 13. Okay. This one looks like a bunch of stuff, but it's okay. This one's actually really easy. So let's start with A and work from there. Arc A is right here, and it starts right here, ends right here, so the inscribed angle that goes with it is 25 degrees. See how easy it is when you draw over the picture? So 25 is half of angle or arc A, so 25 times 2 gives us 50 degrees for A. All right, let's move on to B. Angle B starts here and ends up over here. So the arc that goes with it is this big arc right here, which is a semicircle, which is 180 degrees. So if the arc is 180 degrees, then half of that would give me 90 degrees for part B. All right, moving along to part C. Angle C starts here, and it goes on and ends over here, and it is also attached to the semicircle, so C is also 90 degrees because we know that two angles that intercept the same arc are congruent. Alrighty, I believe we are done, so good luck with that assignment.